Sorry, I was late. I was walking the dog. I figured make her pee before the meeting, but took a little bit longer than expected.
Okay.
So let's see, what do we have? From my end, not much. Last meeting, I messed up with the recording. My audio wasn't recorded. Pretty much the entire demo of the activity definitions got scrapped, I think. I haven't watched back the video, but I believe my brother was gonna scratch it because there was no audio. So what I would like to do is just do a new recording of just that feature. All right, so as I was saying, much progress from my end with Elsa 3. I've been working on the job scheduling, or being able to run jobs in the background from a workflow. Last week, Mohammed, he made a comment, or a question. He asked, what's the difference between a job and an activity? And as it turns out, the only difference would be that an activity executes synchronously while a job executes in the background. But if that's the only difference, maybe we could conceive of different type of activity that can execute in parallel or in the background asynchronously, so that the workflow just acts as a conductor or an orchestrator that's then used to orchestrate the flow of the process. But the activity execution itself can just happen on some queue or in some background thread or whatever. So I've been thinking about that, and I'm going to do a little bit of experimentation around that as well. Might also be a good solution for those workflows that depend on executing work in parallel. So as you know, we have the fork activity allowing you to branch in multiple paths of execution, but it's not really happening in parallel, right? The way the engine works, it just schedules one branch after the other. But as those branches get scheduled, each connected activity gets executed. So this could mean that if one branch takes a long time to complete an activity, because maybe it's making a database call that's very slow, then that means the second branch and maybe the third branch, they don't get to execute until the first one is finished. It could be problematic for some scenarios. The current workaround would be to move those heavy operations to a job, maybe a hang fire job, and then having the hang fire job resume the workflow. So the activity would schedule the job, suspend the workflow, and at that point the remaining scheduled activities have a chance to complete. And then, of course, once the job finishes execution, it will resume the workflow. But if we make this built into the Elsa engine and the runtime, then that becomes a whole lot easier. So yeah, that's a lot of thinking. Not much developing so far.
Okay.
But,
Okay, it could be interesting to also look at what I've been preparing for the parallel execution, because it's kind of related, because it schedules the activities in list. See how that would help, or actually could be using the solution that I've been working on.
yeah,
But
sure.
just for you to let you know, I don't think that if this is going to be a recording, that it's going to be enough of quality to continue, because
Oh yeah,
it's
this is
really
just
hard to follow.
no worries. This is just a community meeting. Sometimes
Okay.
it's interesting, sometimes it may not be as interesting. I do like to pack it with demos because I know that's what I would like to watch, but we're free to talk about anything and discuss anything. It's
No, that's true, but I mean, the quality of your audio, it's really hard to follow sometimes.
oh, so okay, I see. Let me see if I should just switch to my built-in headset. So how about this? Frans, if you can just talk about your findings and your thinking, then that will make for a great recording, and I'll just shut up.
So far, it's been great. For example, if you don't talk about it, I think it's gonna be bad.
I'm ignoring you just not to jinx it.
Yeah.
Yeah, I can demo a bit. So I've been working on a proof of concept about parallel execution and how it would work for the join. The idea is that a join just counts how many times it gets activated.
One question, Frans. Is
Yeah.
it possible for you to zoom in a little bit? It seems a little bit pixelated on Discord.
Yeah, I was wondering how I would share my screen, basically. So I've been working on a little proof of concept about the algorithm to how to handle parallel execution. We talked about that previous times, and I created a few samples of how it should work. Let me just show you how this one works. In this case, we're looking at a simple diagram where we have a fork and a join. And the join is this time configured as wait all. Basically, it means that it needs to have both sides of the elements of the activities that are connected to the join need to be executed the same amount of times before it will continue to the final activity. So it means that whenever which one comes first, do something 1 or do something else 2C, it will not continue until the other one is also executed. The join does this by counting all the incoming connections, creating counters for each. And whenever an activity activates a join or schedules a join, it will then on the execution add that counter to it, so to keep track of what has been executed or not. So
Can I ask a question?
yeah, of course.
So, can you talk a little bit about the reason for maintaining this counter?
Well, the reason for it is that you have to have a track of how many times something has executed. And you could also do it differently, and was thinking about that you would say on the fork, maybe then provide some token and see whether or not both of the tracks have executed that token in order to pass. But that makes it really tricky when you have a really complicated process where you have different forks and different joins that basically not always come from the same fork. And when you look at the 3 options, or actually 4 options, you can always do that by counting the incoming execution times.
Okay, so in this wait-all example, you could have just kept a log of the inbound activities having executed. For example, do something 1 could be recorded in a list that it has executed, and then do something else to C could have been added to that list. And then once the join sees that it has 2 executed activities of the inbound paths executed, it could continue. For that scenario, you don't need a counter, you just maintain a log of inbound activities that have executed. If I understand correctly, for other scenarios, maintaining the counter will help.
Yeah, exactly. You could do it with a list as well. You have to see how you do the counting to have like, okay, there are 2 items in the list, I can continue, because this do something else 2C, for instance, can be executed through another fork and so on multiple times. And then you have to be aware of that from the join. Basically, what you're saying is correct. You can do it by counting just the execution log for that. In this case, I opted for a counter to make it more simply, for me at least.
So to clarify, I wasn't referring to the execution log, but in the join, you can imagine, at least let me explain the way it's done in Elsa 2 right now. The join activity has an internal list where it adds inbound activities that have executed. So every time join executes, it's gonna see what was the previous activity that executed, or actually the other way around. As do something 1 executes, it fires an event, and then join handles this event called activity executed, and then it checks to see if that activity that just executed, so do something 1 for example, if it is a direct parent. If yes, then it will add that to a list, just the identifier of do something 1. And of course, when do something else 2C executes, it also fires the activity executed event, in response to which the join activity adds that activity identifier to its internal list. And then it does a comparison to see, am I waiting for any more inbound activities to execute? If no, then it continues. If yes, it will not continue. So it's unrelated to the activity execution log, but you get the point. I'm just maintaining a list. Not saying that this has to be the same, but I'm just trying to understand the purpose of the counter. What are the scenarios where the counter will increase to 2, for example? So if you start from fork on at the top, then it executes to something 1. That happens once, and the right branch executes once as well. So why maintain a counter? That's the question. But I can imagine that for this simple scenario, it's not necessarily useful, but maybe for other scenarios that you're going to discuss.
Well, it's basically the same thing. It's another way of storing the information about the execution. So when I was referring to the execution log, it was the internal execution log of that join, because it only needs to be tracking the ones that were inbound for him so it has an internal list of the things that gets executed. In my example, I do it a bit differently. I schedule the activities that need to be executed on a ledger and pick up the top 1 to be executed, and then it knows how it was executed executed and counts then from that referring item. So when it will not activate straight away do something else to be, but it says this needs to be executed and it needs to be executed on my behalf. So I issued it. So when something enters the join, it will get a notification, not a notification, but on the list of activities that need to be executed, it says you need to be executing join now on behalf of do something else to see. And that makes it possible that the join can count how many times it was issued by an activity, an incoming activity. Does that make sense? I can show you the code otherwise.
I need to think about it. Yeah, if you can show some code, maybe that makes it a little bit clearer. I was also distracted by my own thinking as you were talking and explaining. I was wondering, will this also work for any other flowchart construction? So between the fork and the join, any kind of activity can execute. Of course, by default, this is a flowchart, but for example, do something else to a could itself be a fork, or it could be an if else, or could be a while loop, etc. Okay,
exactly.
Nice.
That can be the case. If you look at here, let me see. I can make it a little bit bigger. This is the join. So I have a counter. The counter, a list of counters, and whenever it gets executed, there aren't any counters, which is an odd case while it's getting executed. So who is executing this one? It adds all the counters for connecting activities, so the incoming activities. It creates a counter for those. And when it gets executed, it has an activation token. And that activation token is a carrier of information why it is activated. So it holds the previous node. It can have additional custom properties where you can make a custom join, act upon, oh, I'm only gonna count when a custom property is set or an ID is set. And yeah, the clone, not to mix up the stuff. This is basically the carrier of information from one activity to another, and I would like to think it as a flow context, in which context this flow is running. And when it happens, increase counter 4, it increases for the previous node. So if I execute it, you will see it in the demo. Let me start it. So here, when we start, it says next in line to execute is begin. That's the first one that has no incoming, that is scheduled. On the right, you see the activities to execute. So only begin is activated. So when I now perform the step, I execute begin. It just schedules do something for the next one. So now we're on the fork, and when fork gets executed, is executed from do something, it will schedule both do something 1 and do something else 2a to be executed. Then it grabs the top one and it schedules the join after that, because after do something 1, the join will execute. But prior to that, the do something else 2a was scheduled, so it's going to execute that first. And now the join is executed. And in this case, the counters displayed. Do something 1 will be added with 1, because that was the activated from. And the do something else hasn't been activated yet from that connection. Since it's an wait all, it will not execute because it's only one executed once for do something and not for do something else to see. So when this executes now, this is the execution of the join, it will not schedule anything. It just leaves it like do something else to be. When that executes, it will execute to C, and now it comes to the join. The counter for do something is 1, do something else to C becomes 1, therefore both items have been executed, and it will schedule final, and after final it will do the end or the stop, and then it will end.
Very cool.
If you look at wait,
question about the this flow. So is this logic, is it specific to any of these nodes, or is it part of your demo workflow engine?
The counters, what do you mean?
Well, the entire flow, so the scheduling of the next activities, maintaining the counters. I'm already trying to think of how to apply this into the Elsa engine. Maybe you can explain a little bit.
So the engine is as follows. Let me see if let's go to the wait all. So basically this is the process definition, basically the JSON that you also have in Elsa, where you have the activities and you have a lot of connections joining them together. After that, the engine doesn't know about how to execute, only that it holds a record of what he needs to execute. Furthermore, nothing is done there. The activities themselves provide back after a performed step a result, and in that result, this one, it returns an execution result. It says which nodes to schedule next. That are these nodes. It hands over the activation token, and you can have a boolean, and I will tell that in the most elaborate one, what you can do with this, clear all scheduled nodes. So the join is the only one that knows about counters. It's the only one that holds logic to that. All the other activities are unaware of that possibility. They only know, oh, I have an activation token, I need to execute, I do my thing, and I say, okay, schedule next one.
Can we take a look at one of those regular nodes to see how it knows to activate the next one?
Yeah. So activity, for instance, that has a base. Here it says, basically this does nothing because it was short in time, but it performs an execute. It sets the activation token to this after it executes, and then it returns an execution result with that activation token, and it has the connections provided, and it says get outbound connected node for this. And it searches in the connections what is going to be the next or connecting activities.
I see. Yeah, so this makes sense, but this does require every node to be aware of the fact that it's part of a flowchart. So that might become a little bit challenging, but yeah, we need maybe one step too far for now, but it might be a little bit of a challenge to adapt this to the Elsa 3 model where activities are not aware of their outer structure. So this is aware, of course, that it's part of a diagram or a flowchart.
Yeah.
So we're gonna have to see that. But I like the concept in this manner.
Yeah, what you could do is then, if the activity should not be aware of the surroundings and not knowing the connections, what you could do is then hand it over as the execution result and say, instead of providing the nodes that need to be executed, just indicating I'm executed well, continue.
Yeah,
and
exactly.
Hand it over to the engine to determine what is the next one.
Yeah, that would work great. And that engine that you mentioned in Elsa 3 is the flowchart activity, which knows which one to schedule next for execution.
Yeah.
And I like the activation context where it maintains the previously executed node. This might come in handy.
Yeah, I will post this. It's already in repo, so I will share a link to this repo, and you can fiddle around with the code a bit. I will not go over all the details, but let's go over this one, where it's basically the same after the final returns back. Then we can see a bit more about how the counting goes. So it will go to final, it goes back up, and now you will see that here, for instance, it's counted now 2 times 1, and it just continues with the next one, and it keeps on adding.
Can we take a look at the process in full? If you scroll down a little bit, yeah. So fork on, do something, join. Oh, okay, the loop is created using a connection. So from final, it goes back to do something, and then it repeats. So this is an infinite loop.
Yeah.
Very cool.
Yeah, so basically these are just other ways of determining when to continue. You will see on the wait any that it will, after the first join, it will schedule the finals straight away because it's the first one. And after the second join here, it will not schedule the final. So it will stop then, because the first one was already executed.
Yeah, makes sense.
Continue always will basically having scheduled final already now for the first one. Then the next one is activated and it will schedule final again. So that will trigger it 2 times. This one is a funny one, but on this one we can talk about a bit more elaborate ways of determining when to join and when to continue, and even do some funny things with the execution that were scheduled. So bear with me, it's a funny one. So we begin, do something, we fork, and we fork into 3 items. Then we go to a join, and on the right branch as well, but the fork something goes back to the fork 1 to go again in those joins. And this join is not a default one, it's a custom join, and I will show you the code for that. See the custom join here, and in the execute, add once. It increases the counter, but where is it? I forgot it. Oh yeah, here. Get execution result. The counters where the node starts with do, we can add them. If they are bigger than 1, we'll continue. We don't care about the one that comes from a fork because it was called fork. It doesn't hold do, and we're not going to continue. So we're able to do in the custom join all kinds of logic, and that includes also based upon the activation token that you could say, I'm only counting that if a certain property on the activation has been set, or that a fork and join are joined together, because the fork will add something on the activation token like this is my flow context ID, and the join will only respond to or create counters for those specific flow context IDs. And if we look at that, that's one thing more I wanted to add, is that in this one it says schedule next activities or schedule no next activities. So basically it says when the next activities need to be scheduled because these criteria are met, then it will activate the final. But it also sets that boolean to true, which says, okay, whatever else is scheduled, forget about that. We're only going to continue with the final. And that is what you're going to see when I activate this. Just continue swiftly through this. You see that we have now counters. The fork is already on 1, because that is the shortest way. Here, now, we will not continue because it starts not with do and they are not equal or greater than 1. So the fork doesn't have a result. Now it will continue because the do somethings are both equal to 1 or more. But what it is that these activities are bound to be executed. But as I clear everything, I just want to continue now with the final. So if I do next, you see that all other activities are now gone and only this one continues. So if you have a loop that is scheduled to be continuing, you can discontinue that loop by saying, okay, reschedule everything only with the final. I don't think that we should support this out of the box, but it shows that the flexibility is there to come up with other custom joins on different aspects or different counters, different way of counting, and it is up to the one that implements a custom join to determine what the conditions need to be in order to continue.
Very cool.
Yeah, it's a bit tricky to explain, and I hope I did tell you a bit about how the concepts are, how it can be used. But
yeah, I think you did a great job in that regard. It is a little bit complicated, but I get the overall picture. But to be honest, I will have to rewatch this recording and sink my brain into the little details here. But overall, it makes sense. I like it a lot.
Okay, cool. Yeah, I will share the link to the repo so you can also fiddle around with the code itself and see the inner workings.
Yeah, this is a very nice way of showing these concepts using Blazor.
Yeah.
Yeah, very cool. Yeah, man, nice job.
Okay, thanks.
So you think you'll be able to apply this to Elsa 3, the main source code?
Well, we have to think about a lot of stuff now, and I will tell you what I've been thinking about the last couple of days, and that is really tricky. So we see now that we can have loops in flowcharts or in any execution. That means that activities can be executed multiple times. Even if you think about a fork, for instance, where you have a specific context, you might think, okay, the execution is also in a certain context. Take, for example, document flow, approval flow, the sample that you also created, where you send out multiple documents and they need to be approved by 2 persons. When you send out all those forms and you have that workflow running, it can listen to signals for a specific document ID. And you can have a join for that is elaborate on did we both agree upon this document ID. And this is why we have to have that flow context to determine in which document context are we executing this flow. But if you then refer back to a previous executed activity, like for instance get property by name or by name property or so, you actually can have multiple instances where it executed and you're specifically addressing for this context ID. Which means from the 5 times that it's got executed, you want maybe the 3rd result, because that was executed in the context of the item that you're now dealing with. And that makes it really tricky.
Yeah, agreed, because you are executing this in parallel, so you have these multiple contexts. these multiple
Yeah.
scopes, whatever you want to call it. Yeah, this is why the parallel for each in Elsa 2, or one of the reasons why it's not working, because it lacks this context.
Yeah, but if you think about that, that means that basically everything about the execution of the storage of the variables for the execution of activities needs to be somehow related to a dynamic concept of an flow context. Yeah, that's a major overhaul.
Yeah, good point. Because in Elsa 3, one enhancement that has been made is that every activity execution gets its own ID, so that's unique. So if you execute an activity twice, there will be two identifiers, but you need an overall scope so you can relate those executions if you want to
Yeah, exactly.
reference something from a former activity, or even if you store it in a variable, it needs to. Yeah, that's tricky.
Yeah, and I couldn't wrap my head around it, whether or not we're now seeking the edge cases that we shouldn't be supporting, because it can be dealt quite elegantly and simply by saying, well, if you want to execute something in a context, do it in a sub workflow or in a separate workflow instance that is dedicated to that context, and that makes it really easy and also really visible for the context, and that could also be a solution.
Yeah, maybe. At the very least, that is something we could work with today. Maybe we'll find an elegant solution that does not require a separate workflow, but maybe you're right. Maybe it's not worth that complexity. And having an explicit sub workflow makes things easier.
Yeah, exactly. So there are some tough choices to make, I think, here.
Yeah, agreed. Well, we'll give it some more thought and some experimentations.
Okay, cool.
Are we recording this, by the way? I also want to check that again.
Yeah, this is being recorded, so you'll be able
Okay.
to watch back as well. Yeah.
Okay, cool.
Awesome. Okay. Thank you for this elaborate explanation.
Yeah, thanks.
Yeah, you're welcome. My pleasure.
I don't have anything else. Although I did say I would demo the activity definitions, but I will do it separately. It's just a demo of that feature. So I'll leave that out of this.
Okay.
Cool.
Okay, I
Awesome.
will prepare the repo and share it. Shall I put it in the weekly in this blog or in this part of the Discord?
Yeah, that would be great.
Sure.
Yeah. Okay. Cool.
All right. Great work. Unless there's
Yeah.
anything else,
No, not for my part.
then we conclude this meeting. Thanks a lot, guys.
Okay.
Yeah,
Thank
thanks,
you.
guys.
Okay. Bye bye.
Bye bye.
Bye-bye.